Hey there, I'm Ian Peterson. I'm an actor and a lighting console programmer, and I made this. This is Oscillator, and it's essentially a wireless fader and button that you can give to anyone to control a specific fader on your lighting console. So when I work in the film industry as a lighting console programmer, there are many other heads of departments that I have to answer to. And when we have cues or interactives, sometimes those heads of departments want to trigger those. An easy example would be something like a muzzle flash, where the gaffer or the DP or even the director sometimes wants to be the one triggering that, and they want control over the intensity and when it gets fired. With Oscillator, on my lighting desk, I can assign the intensity of the light to go to this fader, and the button to be a flash button for that light, or group of lights. So all they have to do is set the intensity, hit the button, and it flashes. Of course, on the programming side, I can change Oscillator to control whatever I want. The button could become a toggle. The fader could control the color temperature, rather than just the intensity. The button could control a whole series of cues, and the fader could control multiple lights at once, all fading up. Now, hopefully if you're a programmer, you're already seeing the potential of Oscillator. I work with a gaffer who always puts a light on the camera for Steadicam shots and always wants a handle on my board to control the exposure during the take. Well, now I can just hand him Oscillator and he can stand with the DP in the DIT tent. So now I'd like to walk you through how it works and some of the features, and in the end, I'll tell you some things that I'd like to revise. It was very important to me to use a motorized fader because I prefer motorized faders 100% of the time, so it felt hypocritical not to include one. That being said, working with a motorized fader without any robotics background proved very difficult, and I think there are some things that could be improved, as you'll notice. However, the priority of this box is sending data, and it does that extremely well. I view the motorized feedback as just a plus, so if the programmer makes any adjustments to the fader, whoever's operating the oscillator can see it on their end. The OSC in Oscillator stands for Open Sound Control, which is the protocol I'm using to talk to the lighting console, or really any device that will listen. OSC and it having a motorized fader are the reason I called it Oscillator. It moves OSC. I thought it was funny. I don't know. OSC is a widely accepted protocol by basically every major lighting console, and if you're trying to use a device that has a fader that doesn't accept OSC, you can use a program like Chitane to translate OSC into a different protocol. But because Oscillator uses OSC, that means it's console agnostic. I've tested it with Blackout Lighting Console, grandMA 3, and Touch OSC, but anything that uses OSC, so even some sound consoles, are technically compatible with Oscillator. Oscillator has a single USB-C port for power and firmware updates. And on that same surface, it has its power button, which also works as an LED indicator so you know what's going on. On both sides, it has industry standard quarter 20 threads so you could mount a battery solution or a handle. And on the front surface, it has a 100mm motorized fader and a very nice clicky keyboard button. And if you can't tell from how it sounds, it feels great. So the way Oscillator works is it connects to a wireless access point on your lighting network. That can be something as simple as a consumer router. I was using this little guy for all the tests I was doing. Many of us that are running lighting networks on film sets already have a wireless access point set up and are broadcasting Wi-Fi, so it just made sense to connect that way. Once you connect power, you turn Oscillator on by pressing the power button. Oscillator will always boot up with the last configuration it had loaded. If it detects its known network, the LED will instantly glow solid to indicate that it's connected. If it can't find its known network, it will rapidly blink for 20 seconds, and then it will glow solid if it finds it, or it will start to slowly blink. When the LED is slowly blinking, Oscillator will actually generate its own access point. I'll be the first to admit that the LED indicator system is a bit of a lassie interface.
What is it, girl? Is it Jeff?
In that it's not exactly clear all the time what's going on, kind of like a dog barking. However, because there are only 3 states that Oscillator can really be in, I thought the simplicity made sense. I also added that whenever you hold the bump button, the light dims a little, for fun. I've also included a shortcut to get to the mode where Oscillator generates its own Wi-Fi for configuration. You can do this by turning Oscillator off, holding down the front bump button, and then turning it back on. After holding it for about 6 seconds, Oscillator will go into fallback mode and generate its own Wi-Fi network. Any device that has a web browser and is Wi-Fi enabled can connect to this access point, and then they'll be taken to a captive portal immediately where they can configure Oscillator and put in the correct Wi-Fi network. If for some reason the captive portal doesn't load or your device doesn't support captive portals, you can always connect to the oscillator configuration network and then type in fader.box into the web browser. Then you'll be taken to the web GUI. Once you're in the web GUI, this is where you can put in the Wi-Fi network and configure your OSC messages. You'll see at the top there are 3 different slots where you can save a configuration to. Once you've put in all your information, you can choose a slot, save to that slot, and then navigate back and choose which slot you want to boot oscillator from. Once you hit reboot, oscillator will boot and connect instantly and be able to control whichever device you configured instantly. So this allows you to save 3 different configurations. They could be for 3 different networks, 3 different consoles, whatever parameters you want get saved into those 3 slots. So as you can see here with the web GUI, I can seamlessly switch between controlling touch OSC and then blackout lighting console. So that's a pretty solid overview of how Oscillator works. I want to take this opportunity to thank Andrew Nibbi, who was basically my hardware designer. He helped me take my really messy breadboard design and turn it into something sleek and beautiful. He did the 3D printed box, helped me lay out the hardware inside, and also helped me spec some different components than I was originally going to use. I also really want to thank Jeff Brink, Patrick Matz, Charlie Verne, Matt Hadley, and my dad, and a whole host of other people who really help me and constantly inspire me. They're all mad scientists in this industry. I'm constantly learning from them. They help me with troubleshooting and just inspire me to make cool stuff. And I'm so glad to be part of a community that is constantly sharing knowledge and constantly helping each other. The main thing I learned from this project is that hardware is hard. It's really hard. I had really rough ESP32 breadboard prototypes when I was first trying to see if I could even pull something like this off, and then having Andrew help me take that breadboard design and put it on an electro cookie and then slowly slim it down into this has been just truly wild. I've never really done anything like this, so it just blows my mind just looking at it. It's really light. I love using it. I love how everything feels. I think I'll want to make a PCB if we continue to make improvements on it. But going forward, the main things that I want to change are figuring out a better battery solution, either a better way to mount external batteries or build in an internal battery. I definitely want to add an external antenna because the ESP32 uses 2.4 gigahertz, which is so saturated, especially on set. It's what we use for CRMX transmission, and it's what video we'll use sometimes. So there's a lot of stuff clogging that band, and sometimes I can feel the ESP32 really searching for its network. I'd also really like to add an RJ45 port for hardwire Ethernet. And an idea I've been tossing around is an NFC chip, so you can just tap your phone and go to the configuration page. That's a bit of a superfluous feature, but I think it'd be cool. Beyond that, the web GUI is super ugly. It's just bare HTML. Definitely want to fix that. And I definitely need to work more on my algorithm for how the motorized fader responds. But to be honest, not even knowing what PID was, I think it works pretty well. And then from there, I just want to start bringing it to set and testing it out and getting to play with it. So yeah, let me know in the comments what you think. I love this community because everyone's always working on super cool projects. And so I want to know what you're working on. And let me know what you think of Oscillator. If you think it's cool, if you think it sucks, I just want to hear your opinions. And definitely check out Blackout Lighting Console if you want the best mobile lighting console solution. And I'll see you next time.
So I'm just prototyping this right now, but this is a totally wireless fader here, motorized fader, that uses Wi-Fi built into the ESP32 to send OSC messages to any console. So it'll work with Blackout, it'll work with MA, but the problem I'm having obviously is getting MA to send OSC messages back because it sends kind of weird stuff that I had to translate, and the motor on this is like the way I was doing it was a little silly.